Hello, ladies and gentlemen. Today we are going to talk about distance and midpoint formulas. These are two formulas that you actually have already learned, but we are going to talk about them again in the context of right triangles. We are also going to talk about a new line inside of a triangle. So we talked about altitudes earlier this chapter. Today we're going to talk about medians. So first of all, first vocab word is midpoint. And we've already had midpoint, I believe, as a vocab word, but we're going to put it in here just to remind ourselves what it is. It is the point that divides a segment into two congruent segments. So the point that divides a segment into two congruent segments. All right, and then the median. The median is the new triangle word we have. The median is the line from a vertex of a triangle to the midpoint of the opposite side. So the line from the vertex of a triangle to the midpoint of the opposite side. Just like that. All right, so if we were to draw a median, it's different from an altitude. So here's a triangle for us to look at. So here is the corner, when we can use any of them. There are three medians in a triangle. So here's a vertex. And if we want to go to the midpoint of the opposite side, we're going to go just like that. And what our median will do is it'll divide that side into two congruent sides. Right? We could take this point and we could go towards the midpoint of this side and it would divide it into two congruent sides. So it doesn't hit at a right angle like our altitude did, but it does divide it into two congruent sides. So that's what's important about the median. So here, we're going to talk about the distance, all right? So this list of stuff is one way to find the distance between 2 points. And this way to find the distance between 2 points is kind of like the Pythagorean theorem. This is sort of the long way. So to find the distance between 2 points, you label the coordinates for A and B. So we've got point A and we have point B. And point A is at coordinate 1, 6. Point B is at coordinate 8, 2. And then we draw a vertical line down from point A. What this is telling us to do is it's telling us to make a right triangle. The distance formula works because of this principle of there being a right triangle on the graph anywhere that we have a segment. We can always draw a right triangle in there. And when we're drawing a right triangle in there, we can label the lengths of the right triangle. So here we have 4, and here we have 7 across, right? 1, 2, 3, 4, and 1, 2, 3, 4, 5, 6, 7. So this length is 4 and this length is 7. And then if we want to, we will use the Pythagorean theorem, right? To find this length, we could say 4 squared plus 7 squared is equal to c squared, our hypotenuse. And then we could find our length that way. Of course, that kind of takes a while, and we have to do some drawing, and we have to make some triangles. Or we could use the distance formula, and I believe you've already seen this distance formula. So the distance formula says d distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared for any 2 points, and those 2 points, we'll call them x1, y1, so like the first x coordinate and the first y coordinate, and x2, y2, the second x coordinate and the second y coordinate. We also have a formula for the midpoint. You've seen this one before, at least you should have. So to find the midpoint between any 2 points, you add up the x coordinates of those points and you divide by 2, so you're finding exactly the point in between those x coordinates. And you add up the y coordinates and divide by 2. All right? So that's really all there is to the midpoint. You're finding what's in the middle of the x and what's in the middle of the y. So we're going to do both of those things down here here, we're going to find distance and midpoint between a pair of points. So to find the distance and midpoint between 2 points without graphing them, first we'll label them. We'll label them x1, y1, and x2, y2. And then we'll plug them into our distance formula. So let's write the distance formula so that we get used to writing it. The distance formula is just the Pythagorean theorem done in one step. So it's the square root of x2 minus x1 squared. That's actually the a squared portion of the Pythagorean theorem, plus y2 minus y1 squared. That's the b squared portion of the Pythagorean theorem. And notice that the whole thing is underneath the square root. That's because to find c, we would need to find the square root of c squared, and that's what we're doing here. So let's fill in. So we've got the square root of our x2 minus x1. So that's going to be 7 minus negative 1 squared plus y2 minus y1. So that's 5 minus negative 3 squared. So then we say, all right, well, 7 minus negative 1 is 8 squared plus 5 minus negative 3 is 8 squared. And we know that 8 squared is 64, so we'll say 64 plus 64. That's the square root of 128. And we want to keep this as a reduced radical. So we know 128 conveniently is 64 times 2. Bring out the 64 and we get 8 root 2. So the distance between these 2 points is 8 root 2 units. It also says we want to find the midpoint between them. So if we're finding the midpoint between these 2 points, we're going to set up a coordinate. It's going to be x's over here, y's over here. And for our x's, we're going to add them up. So we've got negative 1 plus 7. We're going to divide them by 2. We're going to add up our y's. Negative 3 plus 5, divide by 2. And then just simplify your coordinate here. So negative 1 plus 7 is 6. 6 over 2 is 3. Negative 3 plus 5 is 2. 2 over 2 is 1. So the midpoint between those 2 points is exactly 3, 1. For the next one, we're going to do the same thing, just another example here. So to find the distance between these 2 points, we'll label them x1, y1, and x2, y2. And we'll go ahead and put them in the distance formula. So to find the distance, we're going to have to take x2 minus x1, so negative 8 minus 7 squared, plus y2 minus y1, so 4 minus negative 3 squared. And then we're going to have to simplify, simplify, simplify. So negative 8 minus 7 is negative 15. I'm leaving it in parentheses to remind myself that when I square it, I need to square the negative as well, so that'll become a positive number. Plus, and then 4 minus negative 3 is 7, so 7 squared. So that's going to give me, well, negative 15 squared is positive 225, and then 7 squared is 49. 225 plus 49 is 274. And I'm thinking there's probably not a square number factor of 274. So let's call it that, and we'll call it good. So 274, or the square root of 274, is the distance between those 2 points. To find the midpoint between these 2 points, we're going to take our 2 points. We're going to add up the x's, so 7 plus negative 8. We're going to divide those by 2. We're going to add up the y's, negative 3 plus 4. We're going to divide those by 2, and we'll simplify this coordinate. So 7 plus negative 8 is negative 1. Negative 1 divided by 2 is negative 1/2. Negative 3 plus 4 is positive 1. Positive 1 divided by 2 is positive 1/2. So this set of points, or this segment that connects those 2 points, has its midpoint as negative 1/2, positive 1/2. All right, so let's take a look at the next page where we're going to talk about medians. Whoa, sorry about that. I've got my phone here on a stand that wiggles. So let's talk about medians, how to find them, how to draw them, what they are. So let me see if I can let you see all of that. There we go. If D equals 7, 1, hey, look, they're giving us a blank graph and they're giving us some points. So let's go ahead and put them on the graph. If D equals 7, 1, so 5, 6, 7, 1, E, let's label that as D. E equals 9, negative 5, so 9, negative 5. Here's E. And F equals 6, negative 4. So 6, negative 4, there's F. Find the length of the median from F to DE. Okay, so this is a triangle. It's telling us we have a triangle so that we can find the median. So we'll connect these together to be a triangle. And this is asking us to find the length of the median from F to side DE. And what that means is we're going to find a line that starts on F and it's going to go to side DE. So the first thing we want to do is we want to figure out where on DE the median will fall. Is it going to be right here? Is it going to be here, here? We need to know the midpoint of DE because the median from F to DE is going to go from point F to the middle of DE. So we'll do that by finding the midpoint of DE. Okay, and we can find the midpoint by adding together the x coordinates, so 7 plus 9 over 2. Add together the y coordinates, so that's 1 plus negative 5 over 2. And simplify. 16 over 2 is 8. And 1 plus negative 5 is negative 4 over 2, which is negative 2. So 8, negative 2 is going to be our midpoint. We can go ahead and write that here. 1, 2, 3, 4, 5, 6, 7, 8, negative 2. So there's our midpoint. Our median will go from F to the midpoint of DE. So we can draw that in. Okay, and we can also put the coordinates of the midpoint here, that is 8, comma, negative 2. We need to find the length of the median. Well, that's going to be easy now because I know this coordinate point is an endpoint of the median, and I know F, which is 6, comma, negative 4, is an endpoint of the median. And if I use the distance formula on these 2 points, I'll find the length or the distance between those 2 points. So I'm going to use the square root of x2 minus x1 squared. Either one can be x2 or x1 as long as you keep those the same when you do y2 and y1. So I'll just say 8 minus 6 squared plus y2 minus y1. We'll call that negative 2 minus negative 4. So negative 2 minus negative 4 squared. Reduce this or simplify this. 8 minus 6 is 2, so 2 squared. Negative 2 minus negative 4 is also 2, so that's 2 squared. So we've got the square root of 4 plus 4, which is the square root of 8. And we know that 8 can be reduced to 4 times 2. We can pull the 4 out as a 2. So the distance between the 2 points when you simplify it will be 2 root 2. All right, so 2 root 2 is going to be our median. Find the length of the median from F to DE. There is our answer. All right, we're not going to do this last one using logic to prove. It's an interesting proof, but it's kind of confusing and long, and we don't need to do it right now. So go ahead and work on the homework. Be really careful with the problems involving medians, making sure that you're using the correct median. See the median from F, right? From F is going to go from here to the midpoint of DE. We don't need to use point D or point E when we're calculating this distance. All right, so be careful with the ends of your medians in the homework. But other than that, you should be good to go. So I will see you later.